Hello everyone, in this video we'd be solving rat in a maze problem. Let's read the question. The question says consider a rat placed at 0, 0 in a square matrix of order n cross n. It has to reach the destination at n minus 1, n minus 1. That basically means if you have a square matrix, you are beginning from the top left corner and you have to reach to the bottom right corner. Okay, and we have to find all the possible paths that the rat can take to reach from source to destination. The possible directions of movements are up, down, left, and right. Okay, and 0 means that the cell is blocked, and 1 means that the matrix cell can be traversed. Okay, one thing that you have to notice is in a path, no cell can be visited more than one time, and if the source is 0 itself, then the rat cannot move to any other cell. All right. Okay. And what is our task? Well, here it says we do not need to read any input or print anything. We just need to complete this function where we are receiving two parameters, m and n. This m is the matrix and n is the size of it. And what we have to do is we have to find out all the possible paths in the manner of strings. And then of all the possible paths, we need to make a list out of it and we need to return it as an answer. The thing that we have to keep in mind is that whatsoever paths we are adding to the list are in the lexicographical increasing order. All right, so let's first try to understand the question in a better manner. Okay, taking the first example, assume you have these input values where this is your n and this is your m, and this matrix is given here. As we know, 1 means the value which can be traveled and 0 means which cannot be. Okay, so 0 are the blocked cells. So as we know the conditions, we can create a diagram like this, right? Where we have all these zeros marked as these solid colored blocks, which means that these are the blocked paths and these cannot be traveled. And the rat is here at 0, 0, all right, which is our source where we have to reach till this star. That means this is your n minus 1, n minus 1. All right. This is your source. This is your destination. Now that we have illustrated the question in this manner, the solution will be more clear to you. So let's see. What were the possible directions? We could have moved up, down, left, and right. Correct? We have these 4 possible ways of reaching this destination. Let's see how we have to return the answer. For that, let's calculate one possible path. Okay, assume the rat is beginning from here and it takes one step towards down. So we can say the first step is down. Then assuming it moves towards the right here, then R will be added to this string, assuming this is your string, your path string. And then once your rat is here, it goes to this path, which means down again, and one more down, and then 2 times right will lead us to the destination. Okay, so this is one of the possible paths. If we have to figure out more paths, you can see that instead of going right in the second step, if we would have gone just like this, one more down, the string would change to D, D, and then we would have moved towards this, which is your right. Then again, the same path, down, right, right. Correct? So this is yet another string which can be a possible solution, which is a possible solution. So once we have these 2 strings, assuming these are the only solutions, what we need to do is we need to put them in a list, and then we need to give it back to the function. Okay, this is going to be our answer. So for approaching this, what we should do, what we need. So whenever these type of situation comes that we need to figure out all the paths or we need to go through all the cases, in these sort of questions, we are actually talking about backtracking, because we need to figure out all the possible outcomes, correct? And then it is up to us what outcome or what solution we are keeping and what we are discarding. But for one time, we need to traverse through it. Okay, before moving ahead, let's have a quick discussion in the direction traversal of a matrix. I hope it might be already clear to you, but let's see. If you are here, assume this is your small matrix, you are standing here in the middle at the star position, and the coordinates that you have are x, y. So if you need to move in any of the directions, if you need to move up, right, down, or left, what you have to do? Let's talk about up first. So when you are going up, what you actually are doing is you are decreasing one from your row. You are just climbing up one row. That means you are going one row up and you are not moving the column, correct? So what we are going to do is we are going to do -1 and 0. That means x minus 1 comma y plus 0, which means nothing, right? And that means this is the coordinates of this cell, correct? Similarly, if we talk about similarly, if we talk about right, we have 0 comma 1. That means we are just making one increment, and that too in the column parameter, correct? We need not to touch the row. It is going to be constant. So it will be x comma y plus 1. All right. This will be one step towards right, and so on and so forth. This is how you traverse in a matrix in the direction form. Once you are clear with this, let's see the algorithm of this question. Okay, so what is the very first step? We need to create a list called as answer. I have named it like that. And you need to make an empty string, and I'm calling here path, and I'm calling that variable path here. So what we have to do is the very first thing we should take care of is the corner cases. That means if the first block itself is blocked, that means 0 comma 0 is a blocked position. That means the rat cannot travel anywhere, correct? And if we talk about the other case, which could be one possible case as well, in that case, in your whole matrix, the destination itself is blocked. If the destination is blocked, then howsoever the rat takes any path, it is not going to reach the destination ever, correct? So these are the corner cases that we need to keep in mind, and we should deal with it just apart from the main question. Then what we will do is we will make a DFS function, and we are going to call that. Let's talk about the parameters of the DFS function. We have ij. Ij means the current cell that you are in. You need to give the coordinates of that. Then the matrix, and then you have to pass on visited. Visited again could be any data structure. It could be a set or array, up to you how you are creating a DFS function. But what it is there, what it is going to do and why it is there is because you have noticed there was one note which said that each and every cell that can be only traversed once, and it cannot be added twice in a single path, right? So for that, we need to keep a track of each and every cell that is already visited. If it is visited, we cannot traverse it again, correct? And the other two things that I'm passing here as a parameter is my answer list and my path. Path will be referring to the current path that I'm trying to make in the matrix. And once that path is made, as you can see in this base condition, it says if rat has reached a destination, okay, then what are we going to do? Whatsoever the current path is calculated till now, that means it is going to be one of the iterations of the recursion. And if that is a possible path, that means the rat has reached a destination. What we will do is we will add that path to the answer, to the ANS list, okay? Let's actually see it here. Assuming this is we have this same diagram here. We have one possible path, this one. Okay, so as you've already seen it, it is your down, right, down, down, right, right. Assuming we have calculated this path, until now the value of our path variable is this, correct? What we are going to do, we are going to add this path to our main list, which is answer. All right, and then again we are going to backtrack till this position. We are going to backtrack like this till this position so that we can figure out the other ways. Here, instead of making this decision of going towards the right, we would instead do down, down, correct? We would go down and down, and then further on we'll build up more paths. Okay, what we are going to do here is the next step of this DFS function would be we need to add the cell to the visited, correct? Actually, this is your major implementation of DFS, and this is your base condition. So once you are entering the DFS function, the very first thing that you should do is you should mark the current cell as visited. Okay, so you are marking this as visited. Then what you are going to do, for every other neighbor, at the cell that you are standing, you need to explore every other neighbor. Very basic DFS. And we need to keep in mind that if and only if all the conditions are matched, only then you are going to call the next DFS function. What are going to be the conditions? Assuming this is your rat, you have 4 possible paths, right? The first condition should be that whatsoever path you are choosing should not cross the boundaries of your matrix, correct? So if you want to go up from this position, you cannot, because that is crossing the boundary, right? What could be the second condition for this particular question? Here we have blocked paths, correct? So we need to check for rat in a maze that if the path is blocked, that means we cannot travel that, correct? So we need to pass these two conditions. Once more, keeping in mind the visited condition, if we have already, assuming we are here, we have made this choice and this choice, and we are currently standing here at this cell. We need to make choices from here on. We cannot go up, we cannot go right, we cannot go left either. Why? What is failing here? This is the condition when you have already visited this path. Okay, so the third condition is going to be you are not going to make the further DFS call to a cell that is already visited. Okay, so I hope we have figured out the 3 conditions for our DFS, and once all these 3 conditions are positive, we can make the further DFS call here, right? Once this is done, the second thing is that the DFS function is working. That means we have taken one step further in our solution, which is creating the current path. So what we are going to do, we are going to append the path with the current direction. Okay, so we are going to, assuming we have taken this step successfully, so we are going to append D to our existing string. All right, so I hope the question is clear till now. We are going to see it in detail when we see the code of it. The one thing that you need to keep in mind is once all the DFS calls are done, you need to mark the cell as unvisited. Why? Because we need all the possible paths, and we do not want that if one path is traveled and we come back for the second path, the cells should not be blocked, correct? So once we are creating the first path, we are marking all the cells as visited. So just in the same manner, when we backtrack, we need to keep on unvisiting the cells as well, so that we clear up the path for the next solution. All right. Okay, so here is the coding implementation of the same thing. Let me discuss that in detail. So I have created some utilities here. One is this directions data structure, in which I have all the directions, and along with all the directions, I have one character there, one small string there, you can say, which for down is D, for left is L, right is R, and U means up. Okay, just corresponding to the values that we have seen here in the 4-direction traversal in matrix. Once this direction tuple is made, I have created one more utility, which is your isValid. It is checking that if the existing cell is in a boundary or not. And this is the DFS function that I have designed. Let's try run this code. So the very first thing, I have created one answer array. Then I've checked the boundary conditions that if the source and destination are not blocked, if these are blocked, I'm going to return the empty list as the question states. And if not, then I'm just calling my DFS function. For the parameters, I already have answered. I've created path here, and I've created my visited set here. I'm using a set for visited. You can use one array as well, marking all the cells as zeros and ones. Then you have then the call I've made is 0, 0. M is the matrix. Visited is currently it is empty. Answer is empty and path is empty. This is my initial call. 0, 0 means I'm standing at the source. Once this call is made, we reach here. Okay. Once this call is made, we reach here. We check that ij, if the ij is the destination. That means if we have already reached the destination, if yes, then what we have to do, whatsoever path is constructed till now, we are going to append that in the answer and return, correct? If not, because we are currently I'm talking about the very first condition, it is not going to happen. We are still at the source node. What we have to do, we have to add the source node to visited, correct? Then I have to explore all the possible neighbors of my source node. Then I have to unvisit it, correct? Let's quickly see the dry run of the DFS function that we have just made. Assuming we are at the first call, we are here, okay? What we have to do, we have to check that if this node is destination. No, this node is not destination. Now what we have to do, we have to mark this node as visited, okay? So let me mark this node as visited like this. This is visited. Then what we have to do, we need to explore all of its neighbors. Let's see up. Can we go there? No, it is out of the bound. Can we go towards right? No, it is blocked. Can we go towards down? Yes, we can. Taking up the new call, we will reach here. Then again, the same things. We will mark it visited. We will explore its neighbor. And we are going to make call to one of the possible neighbors, assuming this one. Same condition with this node as well. This is not yet the destination node. We will mark it visited. We will explore its neighbor. For this particular node, only one possible neighbor is there that it can move to, because up is blocked, right is blocked. The previous one, the left one is already visited. It can only take one step, which is towards down, right? Once this step is taken, again, we will check that if this is the destination. No, this is not the destination yet. What we are going to do, we are going to mark it visited, and then we are going to explore its neighbor. It has two possible steps, down and left. Let's talk about down. If it goes down, this is the next node, checking the same thing, marking it visited, exploring its neighbor. We will reach towards here. Doing the same things with this, because this is not the destination yet. We need to mark it visited. We need to explore its neighbor. Unless we reach there. Here, the base case is going to hit, and we have one possible path here. Path till here will be constructed, okay? Because as you can see, I'm adding path with this second parameter of my k, and k here is direction, okay? So once that is done, that means I have one of the possible paths. Then what will happen? This path, which is your down, right, down, down, right, right. This path will be added to answer, and then we will backtrack. How we will do it? We will take one step back. That means all of the neighbors of this cell are explored. We will go back. We will mark this as unvisited. Okay. We will mark this as unvisited. What we'll do, we will backtrack. We will mark this as unvisited. All right. Once the work of this, all the neighbors of this cell are explored, we will go one step back and we'll do the same thing. We'll mark this cell unvisited, and keep on doing till here, till this cell where we had one of the solution is still left. So once we are at this block, this means we have one possible path that we have not traveled yet. Okay, we took this path where we were going down, but this path was still left unexplored. We will go there. We will mark this as visited, correct? Now we will explore all of its neighbor. Well, surprisingly for this node, there is no possible path it can go to. All of the exploration will end here only, and then this cell will be marked as unvisited. Okay. And again, we will reach here and we will backtrack till this block, from here till here. That means this is also unvisited now, right? So do I have any further way from this node I can go to? No. So I'll go back till here. I'll mark this node as unvisited. But okay, before marking this as unvisited, it has one more path that we can go to. It has one more neighbor which is not traveled yet, which is this one. So from further on, we will go here and we will start the exploration from here. And again, this is going to be the further path. So what I mean to say is the next path would be this down, and then right. Correct? Right and right. So now, as you can see, this was the possible path. And now we have, as we have all the possible paths, we are going to add this to the answer as well, and then we can return it finally. Correct? Let's run the code and see if it is passing all the test cases or not. So here is the same code. Let's run it. So it is compiling successfully. Now let's see if it is submitting for all the test cases. Yes, so it is passing all the test cases. Let's take a quick look at the complexity that this question has. The complexity of this question is going to be O 3 to the power n square. Now, why so? Because at every possible choice, there is a possibility that you need to traverse the whole matrix, correct? That means you need to traverse n square, because n square is the complexity of traversing a whole matrix, right? And in the worst case, you might have to traverse the whole matrix, right? And at every point of time, at every point in your DFS function, you have three choices that you can make. Assume you are standing here, correct? And you're coming from there. Then from this point, you have three choices. You can either go there, on the right, on the left, or towards down, because you cannot just go to the previous one. You are already coming from that direction. So what it means is, at every possible step, you have three possible calls, and in each call, you can traverse the whole matrix, right? So for that, the complexity is going to be 3 to the power n square. I hope you understood this question. If you have any problem, you can drop down in the comments, or you can watch this video again, and I am sure that you'd be getting how this question is working. Thank you.